Now, I know that stuff we've just done is quite tricky, but we're going to try now and start applying it to things, because I think the more you see it, the more it's just going to start making sense. Sometimes those diagrams can be extra tricky. So this one says, a uniform rod, PQ, is hinged at the point P. Hinged meaning it's been like kind of screwed into the floor. It's got like a door kind of hinge so that it can move up and down. And it's held in equilibrium at an angle of 50 degrees to the horizontal by a force of magnitude F, which is acting perpendicular to the rod at Q, just like it's shown in the diagram. Given that the rod has a length of 3 meters and a mass of 8 kilograms, find the value of F. So they've already added some of the forces on here, okay? They've added this perpendicular pulling force that's happening. They've added the weight that is happening as well. So really what it looks like in real life is it's sort of like this, okay? So there's a beam like this. My arm here is representing the force F, and the hinge is where it's stuck at the floor like this, okay? There is actually some other forces on this diagram that haven't been included. Can you work out what those other forces on the diagram that haven't been included are? There's a reaction force. There's a reaction force from the floor pushing upwards. There's something else though. Think about what this carpet is like. Think about what this carpet is like. Friction, yeah. If this carpet was icy and smooth, what would happen to this beam? It would slip like this, wouldn't it? So if it would slip like this, which good, the friction must be going in this way. Now actually, this one is not friction because it says it's hinged. So we're going to call it, instead of it being a normal reaction here, we would just call it the upward force, which is Y, and the alongward force, we would just call it X. Don't worry about Y and X for the moment, okay? We're going to do this when we come back to hinges later. But I just wanted to show you there are some other forces that are acting here. Okay, I'm going to redraw the diagram. So we've got this. Oh, that's not very good. Here we are like this. There's a force over here, which is F. We've got 8G, which is coming down. This is 1.5. This is 1.5. And the floor, the angle that it's making is 50 degrees that we've got here. Now this one we can go straight in to taking moments. Because actually if I take moments about here, what can you tell me about those two forces at the bottom? They'll be zero. The forces won't be zero, but the moments will be zero, won't they? Those Y and X won't be included. So if I just call this bit at the bottom, it's P, isn't it? If I take moments about P, it's in equilibrium. So the ones that are making it go anti-clockwise will be equal to the ones that are making it go clockwise. So the easiest one to do is F. What would be the moment for F? 3F, because it's the force is already perpendicular, or the distance is already perpendicular to the force. So it's just the force multiplied by the perpendicular distance, which is 3. This is the one that's a bit trickier, okay? I'm going to draw this triangle that I've got here. I'm just going to draw it out underneath. And it's 1.5, and it's 50. And I'm looking for the perpendicular distance. Now, a couple of people have seen some confusion here. They've said, oh, well, this bit on the side here is 8G. No, it's not. 8G is nothing to do with the distance. 8G is just the direction and the size of the force. It doesn't appear on the triangle. We're talking about distances here. The perpendicular distance of this 8G force, this is the 8G force that's acting like this. From the point, this is the distance, the shortest distance from the point to the line of action of the force. We call the line of the force the line of action of the force. So this is the side that I'm interested in finding. What's the length of that?
1.5.
Good. So the force is 8G and the perpendicular distance is 1.5 cos 50. And I've said that this one is equal to this one. Why did I say they're equal to each other? Because it's in equilibrium. Just like we did with previous moments, one's going in that way equal the one's going in the other way. So we can now just say that F is equal to 8G multiplied by 1.5 cos 50 divided by 3. (1.5 cos 50 times 8G divided by 3, which is 25.2 newtons. Okay? So it's really funny because these questions are, like, for our mind, they're quite tricky. But look at that line of working. F times 3 equals 8g times 1.5 cos 50. You should spend your time making this line here absolutely perfect. If you spend 4 minutes doing this and you think, oh my gosh, I'm spending too long on it, that is the most important part of the entire question, to get that right. If you get that wrong, everything else is going to be wrong. So pause and say to yourself, I know this first bit is important. I need to make sure the distances are the correct distances that we have. Okay, so I'm hoping we're going to have a chance to be able to do some of these questions. If we don't, I'm going to ask that you maybe come back after school today and you just have a go fresh on some of these exam questions that I've got here, because it needs to be done like freshly, I think. This cannot be left until next week. Okay, are we okay for me to go on the next page? Yeah. So, this time we have static rigid bodies. This is the name of the topic, really. And I'm talking about the theme of the things are resting on pegs or resting on the floor. So resting on the floor was actually that one we just showed. Like I had something like this resting on the floor. Resting on pegs is going to be something like this. So it's on the floor and I'm just holding it like this. It's like being resting on a peg, but instead of it being a peg, it's just resting. It's not being held up by someone's arm. It's just resting on something else like this, okay? And I'll draw that on a diagram. So it says a uniform rod AB of mass 40 kilograms and length 10 meters rests with the end A on rough horizontal ground, just like we showed you. The rod rests against a smooth peg C where AC equals 8 meters. The rod is in limiting equilibrium at an angle of 15 degrees to the horizontal. Find the magnitude of the reaction at C and the coefficient of friction between the rod and the ground. Okay, so this is complicated, but I'm going to start off by drawing a diagram that looks as much as possible like what we were just talking about in that scenario. So here is the rod that is lying at 15 degrees to the floor, and it says that the rod is resting on a peg. So if I just show you this up here so you can see it a bit more clearly, it's resting at a peg that's at like 8 meters. So it's got something where it is on my finger here at 8 meters along. What do you think it feels like for my finger? It feels like it's pushing, does it feel like it's pushing down on my finger? It feels like it's pushing on my finger exactly perpendicular to the length of the rod. So my finger is pushing in which direction? Like this direction. Yeah. My finger is pushing in this. My finger's not pushing upwards. My finger is pushing perpendicular to the rod. Because it's a normal reaction. It's normal. So there is my finger. And my finger is feeling a normal reaction over here. I'm not going to put the letter on it just yet. Because there's another normal reaction. Where's the other normal reaction? The floor. So there's a normal reaction here. There's a normal reaction here, which I'm going to call N. Notice how this is going up. This one is going at an angle so that this is 90 degrees like this. Okay, I'm actually going to make that one just a little bit bigger because I think it's going to make the next bit of the question a bit easier. Okay, so that's normal. That's normal. We've still got some missing forces, though. Can you see what the missing forces are? Weight, good. Yeah, let's add in the weight. The weight is 40g. And the friction. Which direction, when I put this on the table, which direction do you think that it wants to slide? It wants to slide like this, doesn't it? It wants to, especially because this is a smooth peg. If my finger was icy and smooth, it's going to want to slide down there and it's going to want to slide off the table. If it's moving so that this is wanting to slide in this direction, the friction must be going in this direction. Just because we say if something's trying to move to the left, the friction must be going in to oppose that direction, just like we did earlier on in the forces topic. And that is all of the forces that we have here, okay? There are, you might look at these questions A and B and you'll be like, oh my gosh, how am I going to do that? I don't really care what the question is asking for you to do. I do, but not really. There are 3 things that you do in this question. There were 2 things you did in a normal question. What were the 2 things you did in a normal question? Up and down, and take moments. So it's the same thing. You are going to resolve up and down. You're going to take moments about a point, and you're also going to do the new one, which is you're going to resolve left and right. So there are only 3 things you can do in this question. If you have no idea how to get to the final answer, you can all resolve up and down, you can all resolve left and right, and you can all have a good go at taking moments. And you'll get pretty much all the marks that there are. Okay? So I'm going to start off. Which do you think might be the best thing to do if what I'm interested in is the magnitude of the reaction at C, which is this thing here? Which one? I think taking moments at this point, I know I probably should have labelled these things. This was A, this was B, and this was C. I think we should take moments about A. Tell me why taking moments at A is the best.
Because you're removing the R force.
Good. I won't have R. And I won't have mu r in there, which is great because I don't know anything about it. So if I take moments there, I'm only going to be involving n and 40g, which is fantastic. So I am going to, for part A of the question, take moments about A. I haven't written all of the distances on here, but we know it was a length 10 and it was uniform. So this must be 5, this must be 3 because it says the peg is at 8 meters, and this must be 2. So what's the moment for the n force? 8 times n. The force is n and the perpendicular distance is 8. Now I'm going to look at this 40g here, and I'm going to, in a slightly different colour, think, okay, well, here is the line of action of the force. This is the point. The distance I'm looking for is the perpendicular distance, which is from here to here. So I'm looking for this distance along the bottom. So you might find it helpful to draw another triangle, only labelling distances. 5, 15. The thing I want is at the bottom. What's the thing at the bottom? 5 cos 15. So my perpendicular distance is 5 cos 15. And my force is 40g. So I get 8n, 1 second, is 40g times 5. I've just written the same thing out. That's kind of pointless. So n is equal to 40g times 5 cos 15 divided by 8, which was what, sorry, 237. Can you give me the longer one? 36.7. A little bit longer?
65.
765?
65, not 7. Just 65. You want even more? 6518.
6518. Okay. Then I'll say that's equal to 237 newtons. Yes, Sadia, what was your question? Are you sure? 100% sure? Because I don't mind a stupid question. Okay, so look at this. Tricky situation, careful diagram. That's where all the marks are reserved. Just because it's a hard question, it doesn't mean it's going to take up the whole page. Quite the opposite. It's not going to take up much of the page at all. Okay, well, I've now... Guys, this is probably the hardest thing we will do in mechanics across the whole year. So the concentration needs to be full the entire time. We've taken moments. There's only 2 things we can do now, okay? Part B of the question, it says, find the coefficient of friction between the rod and the ground. Okay, well, I might not know where to begin, but I've only got 2 things to do. So I'm going to do 2 of these things. I'm probably going to resolve vertically first. I'm going to go up and down. Now, some of these are dead easy. My downward force is 40g. My upward force is r, but then I've got something a bit tricky over here. Because is n going up? No, it's going a bit up and not really up. So I need to say, how much is it going up and how much is it going along? Any guesses of what this angle is?
15.
It is 15, okay? You can work out why this is 15 by saying, okay, well, if this thing here, this whole thing is 180, this is 90, this would be 75, so that would be 15. Or you could say that this one over here must be 75. You can do lots and lots of working out, but that one at the top is 15. So this is why a big diagram is important. What's this force running along here then going to be?
237 cos.
Yeah, I'm going to just use n for now. N cos 15, and running along is n sine 15. Okay? So when we resolve up and down, we've got 40g, which is going down, is equal to r plus n cos 15. That's another 3 marks. 3 marks, 3 marks. It's just marks all over just for writing the first line out. So we can see that r is 40g minus n cos 15. Now we know what n is, so I can just go straight in and actually work out what that is. 163.4. So that's what the normal reaction is, okay? Because we use this value of n to go in here. We're now going to do the only other thing that we haven't done, which is to resolve left and right. Left and right, I've got that mu r is equal to what? N sine 15. Get yourself 2 marks here, okay? In fact, I think this is 3 marks. You get 1 for knowing that friction is mu r, 2 for trying to do left and right, and 3 for it being perfect. So that's 3 marks, 6 marks, 9 marks. This is a huge question. Yeah?
You know when you resolve 40g, it becomes 40g cos 15 and sine 15?
No, because I'm not doing like I did earlier, like what we did in forces like a few months ago is we looked at it and we tilted our vision so that we had to resolve the 40g, but I don't have to here because I've got this is going up and down, this is going down, this is the only one that needed resolving, okay? If you wanted to do it resolving like in this direction, then this would need resolving and this would need resolving, but this doesn't because we're saying resolve up and down, not parallel or perpendicular, okay? So then that must mean that mu is equal to n sine 15 divided by r. Now we know what r is and we know what n is. So mu is equal to 236.6518 sine 15 divided by 163.4118, which is
0.3748.
3748. Now we've done potentially some rounding here, so I'm just going to say 0.37 to 2 significant figures.
You have to use one of them or else you get like 0.36. Like if you don't use one of them, that's not rounded. So
Okay, so use them unrounded.
if you can.
Why am I happy with my answer?
Seems
Less than 1.
reasonable.
It's not negative and it's less. Oh, it doesn't have to be less than 1. Remember, it could be 1 point something, but it's not like 100. It's also not negative. Nothing like that. Okay, it seems reasonable. So let's just break this down. You took moments. We resolved up and down. We resolved left and right. If you can do those 3 lines in yellow, you have got, I would say, 8 out of 10 marks. Maybe more. Maybe 9 out of 11 marks. Okay? The rest is can you type in a calculator, which sometimes I doubt you can when I look at your work and you go like, I can't see what I've done wrong. And then I check your calculator and you haven't typed it in. So I know we've only got 15 minutes, but I actually think it's going to be beneficial for us to do 1 more of these together, and then you can always look back over this and then do something. I'd really like to see you all after school on today just to work on this. This is going to be the most important thing for you to work on immediately. I don't want this left as late homework, okay? So, 1 more?
Yeah.
Okay, this is obviously harder. Have I given you like a double page to do this? Have I given you space to write it on as well? Okay, so first of all, the diagram is reversed, so that can sometimes be difficult. But it's a similar kind of idea that we've got. We've got some unknown angles. It says a uniform rod AB of mass 5 kilograms and length 8 meters has its end resting on rough horizontal ground. The rod is held in limiting equilibrium at an angle alpha to the horizontal, where tan alpha is 3/4, by a rope attached to the rod at C. The distance AC is 1 meters. The rope is in the same vertical plane as the rod. All that means is it's not going at like a kind of a tilty angle. It just means it looks exactly like it does in the diagram. The angle between the rope and the rod is beta, and the tension in the rope is T, as shown in figure 3. The coefficient of friction between the rod and the ground is 2/3. The vertical component of the force exerted on the rod at B by the ground is R newtons. Find the value of R, and then find the angle of beta. Okay, it sounds like really confusing, but just do moments, resolve, resolve, and it will work. Okay, just trust me, it will all work. So let's just pull out some of the things I think we may potentially need in this question. Let's get those to the side. As soon as I see that tan alpha is 3/4, I go straight in and I think what sine alpha is. What's sine alpha? 3/5, because you know that's opposite and that's adjacent. And so cos alpha is 4/5. I know that's going to be useful for me. I'm then going to go back to the diagram and I'm going to start adding on some more forces of things I know that will be required. So they've told us that the whole thing is 8. And we know that it's a uniform rod. So where am I going to put the weight? In the middle. So actually I kind of don't like the 7 there. So I'm going to call this 5G, which means this would be 3, this would be 4. What other forces are missing? R. The normal reaction here is R. And let's just go back to see what they called it. They said the vertical component of the force exerted by the rod at B on the ground is R. That's because there's a friction there as well. This is the vertical one, but there's also a frictional one. Now this one, which direction do we think, because of this person pulling it in this direction, which direction do we think it's going to try and move? So it's going to move like this. If it was here and someone is pulling it at an angle, it's going to try and move to the right, so which means the friction must be to the left. And the reason it has to be to the left is because, look, this force that we've got here is doing a bit of an up work and it's also doing a bit of an across kind of work. So, yeah, so we'll think about how that's all going to come together in just a second. Where do we think is the best place to take moments for this question? B, yeah, it's always going to be at the thing where there's the two forces, okay? Doesn't matter. Oh, well, I guess we could find out what R is.
Because we don't really work with T and B, so you might as well work with them and work out what R is.
I think we could do any of the orders then. Should we do, why don't we resolve up and down? They haven't told us what T is, have they?
That's how like the CC.
Okay, so,
We have to resolve T as well.
yeah, T is going to need resolving because it's at a sort of a funny kind of angle.
Let's do that.
I think we probably should take moments about C. I think if we take moments about C, that way we'll only have R and mu R, and we know that mu is equal to 2/3. We usually take moments about that corner bit, but if we take moments about C, we can ignore what the T part is that we've got there, which is good because we don't know what it is. So we're going to try and take moments about C to try and find out what R is. Now I can ignore what T is, and I'm going to think about what all of these perpendicular distances are to C. This is kind of not fun.
3 multiplied 5G cos alpha.
So first of all, let's deal with this one. Okay, here's the line of action of the force, and we're trying to find from here the perpendicular distance to this bit over here. So if I draw this triangle out again, we have along here, down, along here. This is 3. What's this angle over here?
Alpha.
It's alpha because these are alternate angles, and the hypotenuse of this is 3. The distance that we're interested in is here, D. What is that distance? 3 cos alpha for this distance. So when we take moments about C, we're going to have 5G, which is the force, multiplied by 3 cos alpha, which is the perpendicular distance for it. We're then going to have to do this one. And we want to know the perpendicular distance of this force to C. So now we're trying to find out this whole distance along here. What do we think this whole distance along here is going to be? It's going to be this triangle, long distance,
Cos alpha.
hypotenuse is 7, and that's alpha. We want this whole distance along here. It's going to be 7 cos alpha. So it's going to be R, I think I might need to add something in a second, multiplied by 7 cos alpha, because I've just spotted another force. Which one does the mu R appear to be working with? The 5G or the R? The 5G, yeah, because the 5G is trying to pull it downwards and the mu R is also trying to make it rotate in that clockwise direction. So I need to add something into this side, don't I? So when I take moments about C, we've got mu R, and we need to find if this is the direction of its distance, of its force, sorry, we need to find out what this distance here is. Can we spot what we think that distance is? 7 sine alpha, because here's the big triangle for it. There's a 7 and there's an alpha, and it's the one that's running along the opposite side. So the distance we're looking for there is sine alpha. So we have the force, which is mu r, multiplied by 7 sine alpha. So these two are working together, and it's equal to this one that we've got here. And now we've got an equation that we can solve to find out what r is.
Yes, we can. Who's going to do it?
So I'm going to just sub in all the things we know. So we know that mu is 2/3. So that's 2/3 r multiplied by 7 sine alpha is 3/5 plus 5g times 3 times 4/5 equals r times 7 times 4/5. So this is fun, isn't it? So that's 14/5r plus 12g equals 28/5r. So we get 12g equals 14/5r. And so r is 42.
Oh, gee. Is that an exact number? Oh, I forgot the mu.
Pardon?
Is that an exact?
That's exact.
Okay.
Yep, it's exact.
No, find it. No, do it on A. On the B.
Okay, so this is not fun, this last part. We're now going to try and find the size of angle beta. So we know we haven't done two things in this question. The two things we haven't done is resolve up and down and resolve left and right. So we're trying to take this force, which is T newtons, and we're trying to resolve it into an up force and a cross force. I'm going to just erase some of these lines here for a second, because I think it's going to get in the way of what we're doing. So we go back to the diagram that we had previously. Now, this is the bit that is not so good. If this is beta, this is alpha. 1 second.
Five G is 42 plus T sine beta.
But it's not a sine beta. That's the thing.
Oh. Oh, wait, yeah. Oh no.
Because beta is the whole thing there. They haven't told us that one. So I guess this angle that we have here, if this is alpha, because we can see that it's an alternate angle with this one, this angle is beta minus alpha. This can't be what they want us to do. I'm going to have to check this afterwards and see if I've told you to do it in a completely wrong way. So this is beta minus alpha. This is beta minus alpha. So this one here would be T sine beta minus alpha. And this one would be T cos beta minus alpha. Has that gone too quick, that bit?
Let's see.
Yeah? So the angles that we've got, this angle they told us was beta, but we couldn't resolve it because we didn't know what it was, what the angle was with the horizontal. We only knew this whole angle here. So if the whole thing was beta and this small one down here is alpha with this horizontal line, then this one is beta minus alpha and this one is also beta minus alpha. Because this is opposite, it will be sine. Because this one is adjacent, it will be cos. Now, when we do the resolving, if we resolve in the up and down direction, we can see that r, this one here, plus T sine beta minus alpha equals 5g. Now, we know that r is 42. So T sine beta minus alpha is equal to 5g minus 42. which is 7. Now we're going to resolve in the left and right direction. Just stick with me because this is all going to work out, I hope. Have faith. What's the resolving in the left and right? So you get mu r is going to the left, and that must be equal to t cos beta minus alpha. Now mu is what? 2/3. So it's 2/3 of 42. And 2/3 of 42 is 28. So we have t cos of beta minus alpha is equal to 28.
Oh, we did square.
Even quicker, because we don't care what t is. I only care what beta is. What can I do with this?
Double angle.
Good, I can turn it into tan. How can I turn it into tan? So I'm going to do this one and this one. I'm going to do number 1 divided by number 2. So I get tan of beta minus alpha is 1/4. What is the expansion of tan of beta minus alpha?
That's where we
Tan A plus tan B.
Tan,
Over 2 tan A.
tan beta minus, because it's a minus, tan alpha.
Over 1 plus tan.
1 plus tan beta tan alpha equals 1/4. So if I multiply these things up, if I multiply this up here and the 4 up here, I have 4 tan beta minus 4 tan alpha equals 1 plus tan beta tan alpha. But don't we know what tan alpha is?
Yeah, 3 over 4.
Tan alpha is 3 over 4. So 4 tan beta minus 4 times 3 over 4, which is minus 3, equals 1 plus 3/4 tan beta. So we then get 4 minus 3/4, you get 13 over 4 tan beta equals 4. So tan beta is 16 over 13. And so beta is the inverse tan of that, which is 50.9 degrees. Right, now here's the moment of truth. Did we get it right?
I beg it's from this one.
Yeah, if it's wrong, I'm going home and you don't have to come in next lesson.
Oh, we have to make this recorded.
Yeah.
Okay, good.
But I might go back on my word.
Nah, you
You
can't do that.
can't do that.
You can't do that.
Okay, well, we're still in here, because there it is. So they did come up with it in the way that we did it here. They did come up with the beta minus alpha bit. I mean, like, this is literally the hardest kind of stuff you could come across. What were you going to say, Ruhan?
You know when you had the line tan beta minus alpha is equal to 1/4?
Yeah.
I just did arc tan 1/4 plus arc tan 4/5 and it's beta tan.
Yep, perfectly. What you could have done instead then, if you wanted to do a shortcut from here, we didn't have to use this expansion. The only reason I did this expansion is because here I came up with the exact thing that tan beta was. You're right. What we could have said is beta minus alpha is the inverse tan of 1/4. So beta is the inverse tan of 1/4 plus alpha, and alpha is the inverse tan of 3/4. If you do that, you come up straight away with the answer 50.9. But I just kind of wanted to show you that if they said find out the value of tan beta, you wouldn't have been able to find out tan beta, you would have only been able to find out beta. And then if you did tan of that, you wouldn't have got the exact fraction that you needed there. I'm just going to talk through it all again because it's basically the bell is going to go. And this is obviously the hardest thing that we do. I've deliberately showed you one of the hardest examples as well. But the same things still stand, okay? We took moments. We resolved and we resolved. The resolving was particularly difficult here because they didn't tell you the angle with the horizontal. They told you the full chunk of the angle instead. I'm just going to really quickly draw what it would have looked like if you didn't have to do all of that funky stuff with it. If it was like this, had a force here, the weight here, and if they had a force that was going like this, but they told you what that angle was, then you could have just resolved it along and up. with whatever that angle was, beta, okay? It was the fact that they had given you the large angle is beta that meant that we had to do the beta minus alpha to come up with that particular bit that we had. Do you notice how here it's the angle with the horizontal, which is easier? Here, it was the angle not with the horizontal, so we had to remove the alpha from the angle to be able to resolve it, okay? So there are, I think, 1, 2, 3 questions that are not as hard as that second one that we've done. I want to see all of you come back after school and just try it today, please. I really, really think you should all come and just do that straight away after school, okay?